Oh hey, I didn't see you there. Today we're going to be doing the alternating series test. An alternating series is a series whose terms are alternately positive and negative. Here we have a piece of paper with alternating series test written on it. Okay, so imagine this is an alternating series. What this says is that to determine if the alternating series is convergent, two conditions must be met. First, that the series is decreasing, and the second, that its limit be equal to 0, or the limit of b of n, which is the part of the series that does not include the alternating part, which is this -1 to the n minus 1. And b of n is the absolute value of that part. My colleague Sam will explain that further in a little bit. Alright, so if these two conditions are met, then that means the series is convergent. Thank you.
Alright, now I'm going to illustrate an example of how to determine whether an alternating series is convergent. So here we have the series -1 to the n minus 1 times 1 over n, which is an alternating series, and we have to determine whether this is convergent or divergent. So first we're going to do the first condition, I. So we need to check and make sure that b of n plus 1 is less than b of n for all of n. So first we need to figure out what b of n is, and that's going to be the absolute value of this series. So b of n is equal to 1 over n. So we need to make sure that 1 over n plus 1 will be smaller than 1 over n for all of n. And this is true because the denominator will always be larger by 1. So having met condition 1, we can now go on to condition 2, which is whether the limit as n approaches infinity of b of n is equal to 0. And so to do this, we take the limit of 1 over n, which is b of n, as n approaches infinity. Take that limit, and we can see that the limit is 0. Therefore, it has met both conditions, so we can say that it is convergent.
And there you have it, folks. The alternating, oh, gotta get the thumbs up and the pointer fingers in there. Or which one? Just make up your mind, Sam. There we go.